Now we're going to look at a few special cases. Solve the following. 48x squared minus 75 is equal to 0. Notice if these are the form ax squared plus bx plus c is equal to 0, but b is equal to 0, so there's no middle term here. Now for this type, if we split up this, we get 3 times 16 times x, and we split up 75 is 3 times 25. We notice that 3 is a common factor, so let's take out the 3 to begin with, and we're left with 16x squared minus 25 is equal to 0. Now you might recognise this as a squared minus b squared, which we worked out before was a plus b times a minus b. This is known as the difference of two squares. So a will be the square root of this, which will be 4x, and b will be the square root of 25, which will be 5. So this fully factorised will be 3 times 4x plus 5, 4x minus 5, a plus b, a minus b. The 3 cannot be equal to 0, so we say either 4x plus 5 is equal to 0, which gives that, take away 5, we get 4x is equal to minus 5, and therefore divide by 4, we get x is minus 5 over 4, or 4x minus 5 is equal to 0, which gives, adding 5, we get 4x is equal to 5, x is equal to 5 over 4. So the answer to this case is minus 5 over 4, or 5 over 4. When we got this sort of case, you sort of get the plus or minus the same number. Another type is 18x squared minus 12x is equal to 0. Note this is of the form ax squared plus bx plus c, but c is equal to 0. This is actually the easiest type of quadratic to solve. All you need to do is look at this. We've got 3 times 6 times x for 18x squared, and 2 times 6 times x for 12x. Common factor of 6 and x. Take 6 out and you're left with 3x minus 2. So we've got the situation a times b, very simple this time. So either 6x is equal to 0, which means x is equal to 0, or 3x minus 2 is equal to 0. Adding 2, we're going to get 3x is equal to 2. Dividing by 3, we're going to get that x is 2 over 3. So we've got the very answer, x is equal to 0, x is equal to 2 over 3. So when we've got this type, when c is equal to 0, we don't need to bother with the sum, product, sum, and factors.